we're going to look at the voltage division and the current division. For the voltage division, we have to have a series circuit. As you can see, we have a V of S, and then there's a V1 and V2. They are in series because whatever the current going into R1 is going to go into R2. In series, we need to look at the sharing currents, see whether they're sharing the current or not. Those two elements are in series or not. Okay, so let's do KVL in here. So negative Vs plus V1 plus V2 equals to 0. Then if you move Vs to the other side, Vs equals to V1 plus V2. Now what we're going to do, we're going to use Ohm's law to find V1 and V2. What is Ohm's law? V equals to IR, right? V1 equals R1 and I. Where is I? This is I. And V2 equals to R2 times I. Therefore, from this equation, now we can say Vs equals R1 times I plus R2 times I. Now we can factor out I. Then we have R1 plus R2. Solve for I equals Vs over R1 plus R2. So now we have I. Now we're going to put this into this. Then V1 equals R1 times I. What is I? Vs over R1 plus R2. Just put it into the nice form. R1 over R1 plus R2 times Vs. And then V2 equals R2 times I. What is I? Vs over R1 plus R2. And that is R2 over R1 plus R2 times Vs. So this is the voltage division. Let's take a look at the example. In order to find V1 and V2, what we can do, we can combine this 1K and 2K together and then find the I, and then I times R using Ohm's law to find V1 and V2. However, if we can use voltage division right away, we don't have to find the I. So V1 equals itself 1K, the numerator, and then sum of those two, 1K plus 2K, and then total voltage 5, that is 1 over 3 times 5 over 3 volts. And V2 itself 2K over 1K plus 2K times total voltage 5. This is 2 over 3 times 5. That is 10 over 3 volts. When you do the KVL, negative 5 plus 5 over 3 plus 10 over 3, that will give us 0. So this is good review for Ohm's law and KVL. Now, let's take a look at the current division in parallel. So how do we know two elements are parallel or not? In parallel, they do sharing two nodes top and bottom. These two R1 and R2, we have top and the bottom. They do share top node and the bottom node. So therefore, they are in parallel. Now let's do KCL in this node. Entering I of S equals leaving I1 plus I2. And Ohm's law again, V1 equals R1 times I1. And V2 equals R2 times I2. And if you let this V as the voltage across to the current source, then since they are all parallel, we can say Vs equals to V1 equals to V2. Then this is going to be Vs. This is Vs. Now let's solve for I sub 1. Then I sub 1 equals Vs over R1. And from here, I sub 2 equals to Vs over R2. Now, using this, we have I sub S equals I1, which is Vs over R1, plus I sub 2, which is Vs over R2. We can factor out Vs 1 over R1 plus 1 over R2 times Vs. And let's combine this, make a common denominator, that is R1 and R2. Then the numerator is going to be just R1 plus R2 times Vs. To use these equations, let's solve for Vs. Vs equals R1 times R2 over R1 plus R2 times I sub s, because this was equal to I sub s. So let's plug in V of s. I sub 1 equals V of s, R1 times R2 over R1 plus R2 times I of s times 1 over R1, and R1 cancel out. Therefore, it's going to be R2 over R1 plus R2 times I sub s, and I sub 2, we have V of s, R1 times R2 over R1 plus R2 times I sub s, and 1 over R2 this time, and then R2 cancel out. Then what we have R1 over R1 plus R2 times I sub s. Let's take a look at the example. So let's say we have I sub s as a 2 amp, and the two resistors are parallel, 2K and 3K. We want to find the I sub 1 and I sub 2. If you use this current division, it's very useful. You don't have to combine 2K and 3K and then find the voltage. Use the voltage V1 and V2 and V over R to find I sub 1 and I sub 2. But if we use just current division, we can do I sub 1 equals the opposite 3K over sum, and then total current, that is 3 over 5 times 2, that is 6 over 5 amp, and I sub 2 opposite 2K over 2K plus 3K times total 2A equals 2 over 5 times 2, and that is 4 over 5 amp. 2 amp go into this node and split into 6 over 5 and 4 over 5. Again, this is good review for KCL, Ohm's law, and definitely you need to use voltage division and current division in the future circuit. If we have a complicated circuit, definitely these techniques are gonna be very useful.